Hey guys, I'm John and welcome to Respect Your Intellect. While it's true that we don't know much about dark energy, it doesn't mean we just made it up without thinking. In this video, we're going to talk about what we know, what we don't know, how it behaves, and why we even came up with it in the first place. Let's get started. In standard cosmology, there are three main components to the universe that we need to account for. There's matter, which are physical substances that have mass. There's radiation, which is the energy of electromagnetic waves or of moving subatomic particles. And there's dark energy, which we're going to talk about right now. Dark energy is an unknown form of energy that's hypothesized to permeate all of space. Today, it's the most accepted hypothesis to explain that the universe is not just expanding, but it's expanding at an accelerating rate. Unfortunately, we can't detect it or see it yet. We can only see its effects and try to come up with explanations. Based on various independent sources, it's estimated that the universe is made up of about 5% ordinary matter, 27% dark matter, and 68% dark energy. There are different hypotheses as to what dark energy is and how it behaves, so let's go over a few of them. One is Einstein's cosmological constant. When he came up with it, it was in an attempt to balance out gravity in the hopes of showing a static universe. A static universe was soon shown to be impossible because it would always be unstable due to the uneven distribution of matter in the universe. This, along with the confirmation that space was expanding, led Einstein to call his cosmological constant the greatest blunder in his career, and end up discarding the idea. Some would argue that the greatest blunder was to not actually bring it back when others suggested it, because today it's one of the most accepted hypotheses for dark energy that we currently have. Another way of seeing this is that space is not just empty, but it actually carries its own energy. This would make it a property of space itself. As space expands and the density remains constant, there's more and more of it. Measurements have also been made to estimate the density of dark energy in the universe, which comes out to 10 to the power of minus 27 kilograms per cubic meter. In other words, it's this tiny amount of kilograms per entire cubic meter. This is incredibly small, so it's too scarce for the other forces to interact with, and it's too scarce to detect in a lab, at least for now. When it comes to the cosmos, though, the effects of dark energy are very substantial. This is because even if it's incredibly small, it's uniformly distributed in the entire universe, even where it would otherwise be completely empty. Another is quintessence, which suggests that there's actually a fifth fundamental force on top of the strong and weak nuclear forces, the electromagnetic force, and gravity. This would be a bit like the cosmological constant, but it would be dynamic and able to change over time. There's no evidence for it yet, but it's also not ruled out, so this is purely a hypothesis with some merit as it stands today. Another hypothesis is that there are temporary particles that come in and out of existence which would contain energy and essentially be what we know as dark energy. Another one is interacting dark energy, which attempts to encompass both dark matter and dark energy to explain how they modify the laws of gravity. Another is variable dark energy, which attempts to explain how dark energy actually changes as the universe ages. And finally, there's the hypothesis that there's no dark energy at all. With this one, scientists are attempting to use existing theories to explain that dark energy is not necessary to explain all the behaviors we see. So as you can see, dark energy is very hypothetical in nature. So why do we even talk about this if it's so uncertain? Well, there are a couple of independent sources that confirm the existence of energy that we can't detect. But the main one is the discovery that space is not just expanding, but accelerating. Any acceleration requires a force, so something has to be there to cause this acceleration. Distance measurements and redshifts also suggest that the universe expanded more in the second half of its life, so it's getting stronger as space expands. Other than that, there is also a theoretical need to explain the energy we see that isn't dark matter or ordinary matter. We can't just ignore it if we know it's there. We can detect the effects of dark energy by looking at standard candles like type 1a supernovae, studying the cosmic microwave background, observing gravitational lensing effects, as well as the large-scale structures of the cosmos like stars, quasars, galaxies, and galaxy groups and clusters, all of which agree with an approximate 70% dark energy in the universe. So these sources, along with perhaps a few other ones, essentially confirm that we're missing something with our current knowledge of the cosmos. So what we did is that we gave a name to the solution even though we can't explain it yet. Lastly, we can't really talk about dark energy without talking about the theories we have about the fate of the universe. There are a couple of different theories about how the universe might end. One is the Big Freeze, or heat death, where the universe continues to converge towards absolute zero temperature as it expands. Stars would continue to form for a couple trillion years, but then eventually the supply will be exhausted and no new stars will be born. Then the existing stars would gradually exhaust their fuel and the universe would grow darker until black holes dominate the universe. Even black holes emit Hawking radiation and would disappear over time. This scenario is compatible with the three others we'll be going over right now. One of the other scenarios is the Big Rip, which suggests that space will continue to expand at an accelerating rate until all matter is eventually torn apart. This would start with large-scale objects like galaxies and eventually even rip apart atoms themselves as dark energy overcomes the strong nuclear force that holds atoms together. This would result in a universe with only elementary particles and radiation floating around. Another scenario is the Big Crunch, which is the opposite of the Big Rip, where the average density of the universe would be enough to stop its expansion and start collapsing in on itself. This would eventually lead to a reversal of the events we observe after the Big Bang. Eventually, it would collapse into a tiny universe that's full of energy. Then there's the Big Bounce, which suggests that the Big Crunch wouldn't be the end of the universe, but would continue in a never-ending cycle of Big Bang and Big Crunch events. Since there's nothing at the moment that suggests that the universe would ever slow its expansion and allow gravity to take over, the Big Crunch is not really a contender anymore as it stands today. The most accepted hypothesis about the fate of the universe right now is the combination of the Big Freeze and the Big Rip. All the evidence that we have right now seems to suggest that dark energy is uniformly distributed in space, which also means that space is expanding in the same way from every location. This supports the hypothesis that the universe will continue to accelerate its expansion until someday the expansion will move things away from each other faster than the speed of light. This will rip everything apart and leave only elementary particles and radiation, no atoms and therefore no matter. If things never collapse back in on themselves, then it's also inevitable that the universe will exhaust its current fuel for stars and will eventually grow cold and dark as well. Although this may look like a grim future, we would be extremely lucky to still be around when this happens. This is more about answering the questions about the fate of the universe to better understand it than it is about controlling it, because it won't happen for trillions of years. There's always the possibility that with the very limited information we have, that we're wrong about some of these, and that the universe actually does recycle itself. But even if that's the case, it's still not something we'd be able to survive. I'll have another video coming soon about dark matter, so if you'd like to know more about that or other interesting science stuff, make sure to subscribe and click the bell notification. If you have more topics to suggest, let me know in the comments. If you liked this video, please hit the like and subscribe buttons. If you'd like to support the channel, you can visit my Patreon page for more information. For everything else, you can go to respectyourintellect.com and everything will be available there. Until next time, thanks for watching, and remember, respect your intellect.